Assalamualaikum warahmatullahi wabarakatuh and good day. Today we are going to learn about the convolution theorem. Okay, you can use this theorem to find the inverse Laplace transform when we have the function in the form of fs times gs. Okay, the theorem says that let ft and gt be piecewise continuous on the interval 0 to infinity, and if inverse Laplace of fs equals to ft, inverse Laplace of gs equals to gt, then the inverse Laplace of fs times gs is equal to the integration of fu gt minus u with respect to u with the limit of u equal to 0 to u equals to t. Alright. Okay, let's discuss the first example. Find the inverse Laplace transform of the following functions using convolution theorem. So we have the inverse Laplace of 4 over s squared plus 4. Okay, so we know that we can split the equation into two equations. So 4 over s over times s squared plus 4 equals to 2 on s times 2 on s squared plus 4. Okay, why did I choose to have this form of functions? So because we know that this is 4, okay, a equals to 2, then you can just simply put 2 here, so that what's left here is 2 on s. Alright, so we're gonna just choose choose one of the function equals to fs. So let this equals to fs, and the second function equals to gs. So fs equals to 2 on s, the inverse Laplace of fs ft equals to 2. Alright, then we're going to we're going to change the variable to u. Ft equals to 2, therefore fu equals to 2. Okay, let's take a look at gs. Gs equals to 2 on s squared plus 4. So we know that the inverse Laplace of gs is equal to sine 2t, and the shift or the change of t to t minus u, we are going to get sine 2. We're going to just simply replace t to t minus u. Alright, so from the convolution theorem, the inverse Laplace of 4 on s squared plus 4 is equal to the integration of fu, this is fu, and we know that sine 2t minus u is gt minus u. Okay, then we have cos the integration of 2 sine 2t minus u with respect to u. Okay, when you solve this, what you get, this is equal to minus 2, since integrate sine is minus, cos 2t minus u divided by minus 2, where I differentiate the angle of the cosine 2t minus u with respect to u, then I get minus 2. You can simply cancel out the minus 2, therefore you're going to get cos 2t minus u. Then just substitute the limit. When you substitute t is 0, t minus t is 0, so cos 0 is 1, then minus, you substitute u equals to 0, then you're going to get cos 2t. Alright, so this is the final answer. Okay, I'm going to skip example 2. You can just look at the solutions by yourself. Alright, next is an example when it is involved two types of function, which is a polynomial and exponential function. So we have the inverse Laplace of 1 over s minus 1 squared. Okay, when we can split the function into two functions, so this is the inverse Laplace of 1 over s times 1 over s minus 1 squared. Okay, so actually you can just choose either function to be fs or gs. Okay, by choice is I want to let the fs equals to 1 over s minus 1 squared. Alright, and gs is equals to 1 on s. Alright, but you can just simply swap the functions. You can let fs equals to 1 on s and gs equals to 1 on s minus 1 squared. You will get the same answer at the end. Okay, doesn't matter. Alright, so fs equals to 1 over s minus 1 squared. Then the inverse Laplace of 1 over s minus 1 squared using the first shifting property, we're going to get t exponent t. Okay, then we replace t to u, they get fu equals to u exponent u. Here gs is equals to 1 on s, gt equals to 1. So gt minus u also equals to 1 because 1 is as a constant. Right, so the inverse Laplace of 1 over s minus 1 squared equals to the integration of u exponent u from the fu, right? Okay, times gt minus u, and we know that gt minus u equals to 1. Alright, then we get the integration of u exponent u du. Okay, which means you have to apply the integration by parts, or in a shorter way you can just use tabula method. So we have you're going to choose u as a function that you need to differentiate, and exponent u function that you need to integrate. Alright, then u differentiate, you get 1, differentiate 1, you get 0. Okay, this is how you integrate exponent u. So cross multiplication, then we're going to get u exponent u minus exponent u. Okay, simply substitute the limits, then you get the final answer is t minus 1 exponent t plus 1. Okay, let's discuss example 4. So we have inverse Laplace of 2 on s squared plus 4. So this is equals to the inverse Laplace of, we split the equation into two equations, 1 on s squared times 2 on s squared plus 4. So we have to make sure that when you multiply these two functions, it's equal to the given function. Alright, you're going to set one of the function equals to fx and the other one equals to gs. So fx equals to 1 on s squared. Alright, so this is fs, and the other equation is gs. So fs equals to 1 on s squared, ft equals to t. Okay, so we're going to change variable t to variable u. Alright, so ft equals to t, therefore fu equals to u. gs is equals to 2 on s squared plus 4. The inverse Laplace of gs is equal to sine 2t. Alright, so we're going to change the function t to t minus u. Therefore sine 2t becomes sine 2t minus u. Okay, we're going to put these expressions in the integral formula of convolution theorem. So we have the integration of u comes from fu, and sine 2t minus u is gt minus u. Okay, once we have put into the integration formula, okay, we can see that in order to solve the integration, we have to use integration by parts or tabular method. So this is the tabular method of the integration. So we have the column of differentiation and integration. We choose u to be a function that we want to differentiate because we can differentiate until we get 0. Alright, and sine 2t minus u is the function that we need to integrate with respect to u. Okay, so we have solved the integrations. Okay, cross multiplication. Okay, be careful with the sign of the multiplication and also the integration. So we're going to get equals to 1 over 2u cos 2t minus u plus 1 over 4 sin 2t minus u. Okay, with the limits of upper limit u equals to t and lower limit u equal to 0. Substitute the limits, then you get the final answer is 1 over 2t minus 1 over 4 sin 2t. Okay, when you substitute t equal to 0, cos 0 comes equals to 1, so you get 1 over 2t. Sin 0 here is 0, then minus, you must substitute the u equals to 0, so the first term is 0, so the second term is equals to 1 over 4 sin 2t. Okay, this is example 5. I just go through the solution. So we have fu equals to exponent u, gt minus u equals to cos t minus u, right? And then you can see that the integration formula of convolution theorem, you're going to get, you have to solve the integration of exponent u cos t minus u. You can see that is a multiplication of exponent function and trigonometric function. Okay, so in order to solve the integration, again we're going to apply tabular method, but you can see that it's a repetitive differentiation, also repetitive integration. So this is how you solve the integration. I think you have done this before. Okay, I've shown you the solution here. Alright, so you can take your time to try to solve the question by yourself, okay, and refer to the working calculations that have been shown in this slide. Okay, few questions that you can measure your level of understanding, your level of comprehension about this topic. 5 questions altogether, okay, with different types of functions and different way of how you solve the integration. Right, the answers are given. Okay, you can try to answer the questions couple of times until you get the correct answers. Okay, thank you so much for your attention and your time watching this video. Okay, you can test understanding on this topic by answering the IVL comprehension quiz in ULearn. Right, thank you so much. I'll see you in the next topic. Bye.